This video will explain the basics of doing a vegetation analysis with focus on Arctic vegetation. There are two main ways of describing vegetation: structural and floristic. Structural data can be external morphology, life form, size, functional group, and so on. Whereas floristic data is when species in an area are identified and their presence, absence, or abundance are recorded. In this video, we will focus on the floristic way of describing vegetation. Some of the problems with floristic data can be that identifying the species can be difficult. The decision to whether or not collect data on abundance of each species and how to measure the abundance, and if it's necessary to describe the vegetation at species level. Sometimes a different way of describing the vegetation can work better. This depends on your research project aim and objectives. The tool used for floristic data collection is quadrats. Quadrats establish the area where you will be doing your vegetation analysis. They come in different sizes and you need to decide beforehand which will work best for your needs. Some have cross-wiring, which divides your area up and makes it easier to accurately record the vegetation found inside of the quadrat. Some also have two layers of wiring, which helps you pinpoint at a 90-degree angle. Random sampling and stratified random sampling. A habitat is usually not uniform in its composition of vegetation. In theory, random placement of the quadrats should be able to estimate an accurate result of the vegetation composition, but depending on how many quadrats you choose to use, you can end up by missing certain hotspots where the vegetation is significantly different from the rest of your habitat. In order to make up for this difference, a habitat can be divided into one or more strata. In this example, our heat tundra has been divided into two strata that has more detailed level representing two different communities. In the more sheltered heat tundra, occupying 75% of our habitat, we find 20% dryas, whereas in the more exposed heat tundra, occupying 25% of our habitats, we find 60% dryas. We want to do 12 quadrats, so to make up for this difference, we will then specifically place 3 of our quadrats randomly in the smallest strata, and the rest will be randomly in the larger strata. This example is more for capturing the general composition of this specific habitat, but sometimes you can have a plan to look into a specific comparison, like focusing on the difference between exposed and sheltered heat. Then you should place your quadrats in equal amounts in the high dryas concentration area and in the low concentration area. Random recording what's inside of a quadrat, a fast and simple way of getting data is to just check for presence or absence. You basically just check if a species is present or absent inside a quadrat, and you don't measure any form of abundance. This data can be used to estimate the species richness. When you want to record the abundance, there are two methods, one objective and one subjective. The objective method is the pinpoint method, where you use some type of sharp small tool. You can use these marker flags. The tool is pinned at the cross section, and what it touches is basically what to record. So here we have created a type of fake vegetation using tea bags and napkins, and we will compare the objective with the subjective method. First up is the pinpoint method, and here we also account for overlap by counting more than one in some cases. And here you can have a quick look at the result from the pinpoint method. We accounted for overlap in this example, so our results goes above 100% in the cover. Then we are moving over to the visual method. When you're doing a visual analysis, it really depends on who is doing it. but it's something you get used to after a while of performing this method. So what you do is that you use the grid to get the percentage, and then you just have to imagine the different species and try to separate them, and maybe even try to imagine them being down in a corner and see how much space they take up. And also remember to account for the overlap. Then at this point, you can try to pause the video and estimate the cover yourself. Then here you can see the estimate I came up with. And since we control the environment, we will try to also get a really close estimate of the reality. And this was done by using a software that counted the pixels that each of the plants and soil covered, and also accounting for overlap. So this is the reality, and then we will compare that with the two different methods we have tried out. And as you can see, they are all really similar, and it's really up to you when it comes to which method you want to use and what you prefer using. And it's important to remember that this was done inside with napkins and tea bags, and in the field it will be a completely different situation. But hopefully this will give you an idea how to approach getting data on vegetation out in the field.